Hello class 7, welcome back to the third chapter, Elements, Compounds and Mixtures. We will do the second half of the chapter, that is the states of constitutive of mixtures, and we'll deal with different types, different methods of separation of mixtures. Okay, so let us talk about the different types of mixtures that we can have. Okay, there are different types of mixtures we can have. Number one, solid mixtures. Like if you want to separate, we have a mixture of iron filings and sand, or maybe sulfur and common salt and so on. These are solid mixtures. Next is we have solid liquid mixtures. So solid liquid mixtures we have like salt and water, sugar and water, solution of copper sulfate and water, and so on. Liquid mixtures, we can have a liquid mixtures like water and alcohol, maybe oil and water. Liquid gas mixtures like carbonated water that we have for the cool drinks, air dissolved in, or carbon dioxide dissolved in water. Then we have gas and gas mixture, like air is a gas and gas mixture, and solid gas mixture like smoke particles or the soot particles that are suspended in the air. So we have different types of mixtures. Now we will deal with different methods of separation, different processes that are used during the separation of mixtures. The first one will be very common, sublimation. So let me tell you what sublimation is. Sublimation is the process of changing solid directly into gas without changing in a liquid state. For that, we have to know those substances which sublimes on heating. Those substances that sublime on heating are ammonium chloride, camphor, naphthalene, iodine, and so on. These are the main four substances that sublime on heating. Let me repeat it once more. Ammonium chloride, iodine, camphor, naphthalene. These are some of the substances, solids that sublime on heating. That means they directly change, when heated, they directly change into vapor state without changing into liquid. Now, suppose we have a mixture of sand and iodine, or maybe ammonium chloride. What do? We use an evaporating dish. In the evaporating dish, we have the mixture of, let's say, ammonium chloride and sand. Okay, we have a mixture of ammonium chloride and sand, and we are separating them. How do we separate it? We use a mesh over here, and then we use a tripod stand. And in the tripod stand, we have a Bunsen burner. What do we have? A Bunsen burner, from where it is heated with a flame. Now we cover it up with a funnel, a glass funnel. We cover it up with a glass funnel, and the tip of the glass funnel we cover it up with cotton. We put cotton here. Now what happens is when you heat the mixture of ammonium chloride and sand, ammonium chloride sublimes on heating. Ammonium chloride sublimes on heating, but the sand has no effect by the heat. That means sand will not sublime on heating. So it's only ammonium chloride. So we have the ammonium chloride vapors, white ammonium chloride vapors coming out of the mixture from the evaporating dish. And what happens is, since the mouth of the tip of the funnel, the glass funnel is blocked with cotton wool. So what happens is, in the cooler parts of the inverted funnel, ammonium chloride will condense back into solid, thus separating the mixture of ammonium chloride and sand. So at the end, after all the ammonium chloride sublimes, what is left in the evaporating dish? it's only the sand. Ammonium chloride, you find it here on the cooler parts of the inverted funnel. Now we come to the next process of separation, that is evaporation. Now when we talk about evaporation, what is it? It is just a mere process of changing liquid into its vapor state, is known as evaporation. Now evaporation takes place at any temperature, but boiling is also a process of changing liquid into its vapor state, but at a particular temperature at its boiling point. Evaporation is a slow process, whereas boiling is a rapid process. It's a fast process. Boiling takes place at its boiling point at a fixed temperature, whereas evaporation takes place at all temperatures. Suppose if you have, like we talk about common salt or the rocks, or the common salt that we use in the kitchen. How do we get it? Now, the shallow pit is dug in the field, and what happens in the ground, or maybe on the seashore, and they put seawater in it. They fill the shallow pit with seawater, and the sun shines, and the heat of the sun evaporates all the water, leaving behind the sand. So this is how we can separate the mixture of sand and water by evaporation. The other one is, the process is distillation. The other process is distillation. So we have a separate apparatus for it, for distillation. The figure is given on page number 29. You can refer to your textbook, page number 29, and you will see the apparatus. In this apparatus, what happens is the boiling, the evaporation and condensation. Now, what do you mean by condensation? Boiling, you know, boiling is the process of changing liquid into its vapor state at a particular temperature. That is called boiling. Or evaporation is the process of changing liquid into its vapor state at any temperature. That's the difference. Evaporation takes place at any temperature, whereas boiling takes place at a constant temperature. But both processes means it is a change, the change of state of liquid into its vapor state. Okay. Now, evaporation and condensation takes place simultaneously in this process called distillation. So let me talk about the condensation. The condensation is the process of changing the vapor into, or gas into its liquid on cooling. So when we boil water in a kettle, from the spout of the kettle, what comes out? A lot of water vapor comes out. And just keep a cold steel plate at home, cold steel plate in front of the mouth of the spout of the kettle, where a lot of water vapor is coming out. What happens is, when the water vapor comes into contact with the cool surface of the plate, what happens? It condenses back into its liquid state. So this process of changing gas into its liquid state is called condensation. So distillation is the process, in a special apparatus, the distillation is the process of simultaneously taking place. What takes place? Evaporation on the one hand, on the other side, condensation takes place. So distillation is the process of evaporation and condensation taking place simultaneously. Okay? So in the process of distillation, in the process of evaporation, if you have the mixture of sand and water, and how do you separate it? Suppose we use evaporation. Suppose you use evaporation to separate sand and water. What happens is, when you heat it, the water evaporates. We cannot get back the water. We can only separate the mixture of sand and water. We only get the sand. Water, we do not get it because it will evaporate. Go off. But when we use the same mixture, we use another process of distillation. We use distillation. We get that sand as well as water. The water evaporates and the water vapor will condense back, and then we get water again. So we are getting sand. What is left behind in the round bottom first? The sand, and in the condenser we get water. So when we use the distillation, we can get both the constituents of the mixture, sand as well as water. Now, when we talk about the separation of liquid-liquid mixture, now there are two types of liquid mixture. One is miscible liquid and the other is immiscible liquid. Miscible liquid like alcohol and water. Yes, milk and water, juice and water. These are miscible liquids. And immiscible liquids are those which do not mix together, like oil and vegetable oil and sand, water. Maybe petrol and water, or diesel and water. They do not mix. So those liquids which do not mix together, we have immiscible mixtures and miscible liquids, and in the miscible liquids we have mixture of alcohol and water, or maybe milk and water, and so on. Now, if we have to separate the mixture of we have a mixture of miscible liquids like alcohol and water. How do we go about it? We do it by the process again by distillation. But this process, the process of distillation used in the separation of miscible liquids, is known as fractional distillation. Over here we use the different boiling points of the liquid. Like for example, if we have a mixture of, let's say, alcohol and water, they have different boiling points. Alcohol boils faster than the water. Maybe alcohol has somewhere around 80 degrees Celsius is the boiling point, whereas the boiling point of water is 100 degrees Celsius, isn't it? So therefore, when we heat the mixture, the alcohol boils off faster than the water. So therefore, what we get is, we condense the the alcohol evaporates, and the vapors of alcohol is condensed back in the container, and it is collected, leaving behind the water which boils up later on. So we need not boil it again, the water, isn't it? So we have already separated the mixture of alcohol from the water. How? Because alcohol boils up faster than water. So all the alcohol will evaporate, and it condenses in the process of distillation, and it condensed in the same process, it is condensed back into liquid alcohol. So that's how we separate the mixture of alcohol and water by the process of distillation. And this process of distillation, which is used in the separation of miscible liquids, is known as fractional distillation, where we use the different boiling points of the two liquids which has been mixed. Now we come to the separation of the last separation, the separation of immiscible liquids like oil and water. We have a separating funnel. What do we have here? We have a separating funnel. A separating funnel looks somewhat like this. Okay? It's just a funnel with a stopper here. We have a stopper or a tap, whatever you call it. We have a stopper here. And then we have a lid, right? We have a lid here. Now, in the in the separating funnel, we have a mixture of two immiscible, like oil and water. Oil and water. This is how we separate it now. We have a mixture of oil and water, both the liquids are immiscible. So you know, oil is lighter than water, therefore it floats above the layer of the water. So therefore, now we open the stopper slowly. We open the stopper slowly and we allow the water to drop down slowly. Okay? As the level of the water falls down, we unwind the stopcock and block the oil from dropping down. So that's how we separate the mixture of oil and water by using a special apparatus called separating funnel. So with this, we come to the end of the chapter, elements, compounds and mixtures, which will be followed by the notes in the offline class. Okay, in the WhatsApp group, I'm going to upload some of the notes on this chapter. In the next class, we are going to discuss the objective questions in the exercises page number 33 and 34, and will be followed by the notes. So I hope you understood and enjoyed the class. Thank you so much.